Let's explore how compilers transform human-readable code into machine instructions. A compiler is a special program that translates source code written by humans into machine code that computers can execute directly. Let's start by understanding what a compiler does. A compiler translates high-level programming languages, like C or Java, into low-level machine code. Unlike interpreters, compilers perform all translation before the program runs. The compilation process has four main phases: lexical analysis, syntax analysis, optimization, and code generation. The first phase breaks source code into meaningful tokens. Lexical analysis, performed by the lexer or scanner, breaks source code into small units called tokens. For example, the statement int x equals 5 plus 3 is broken into tokens: keyword int, identifier x, operator equals, number 5, operator plus, and number 3. Each token represents the smallest meaningful unit in the programming language. The second phase checks if tokens follow grammar rules. Syntax analysis, done by the parser, creates an abstract syntax tree that represents the program structure. The tree structure shows the assignment operation at the root, with variable x on the left, and the addition operation on the right, which has operands 5 and 3. The parser also verifies that the code follows the correct grammar rules of the programming language. This phase checks if the code makes logical sense. Semantic analysis checks type correctness, verifies variables are declared before use, and ensures operations are valid. For example, declaring an integer x and assigning it a number is valid, and using x in another expression is also valid. If there are type mismatches or undeclared variables, this phase reports semantic errors. The optimizer improves code efficiency without changing behavior. The optimization phase improves code to run faster or use less memory while preserving the original program behavior. For example, the expression 5 plus 3 can be computed at compile time, replacing it with the constant 8, making the code more efficient. Common optimizations include constant folding, where compile time constants are pre-calculated, and dead code removal, where unused code is eliminated. The final phase produces the actual machine code. Code generation translates the optimized intermediate representation into actual machine instructions for the target processor. A simple addition like x equals a plus b translates to several assembly instructions: move a to register 1, add b to register 1, then move register 1 to x. Let's see the complete compilation process in action. The complete pipeline flows from lexer to parser to semantic analyzer to optimizer to code generator, transforming human code into machine instructions. Each phase takes the output of the previous phase and transforms it further, creating a pipeline of transformations. The end result is efficient, executable machine code that the computer can run directly. Let's summarize how compilers work. Compilers are sophisticated programs that translate source code to machine code through multiple well-defined phases. The process includes analysis to understand the code, optimization to improve efficiency, and generation to produce machine instructions. Understanding how compilers work helps programmers write more efficient code and debug problems more effectively.